one of the things I love about the ecosystems that we build and how networks are getting more connected is that I randomly found a taxi off the plane, and I was with some people, and they were saying, oh, we're going over here, so I went here. I mentioned, and one of those people was talking when Lonnie was nearby, and mentioned my name, and said, oh, there's this TED. And Lonnie's like, Megan Smith's here? So he texted me, this is your first time on Martha's Vineyard.
Right.
Yeah.
Right.
And it's my second time. I came when I was 15, actually on a tall ship as a kid in a crazy thing. It was an internship program. I got a scholarship, so I did that. So it's to us, it's thank you to all of you. It's beautiful to be here. We were just talking about that. So Lonnie, you have an amazing history. You did mechanical engineering. I did that too. Yes. And then you did nuclear engineering. Amazing. And you went into JPL. And first you were in the Air Force and then JPL. So say a little bit, because I know you worked on Galileo, as John said, on the nuclear
So
power plant.
let's see, where do I start? So I was in the Air Force first. I was commissioned as an officer at Tuskegee University. And went on active duty at what was then the Air Force Weapons Laboratory, Air Force Research Labs. There I was introduced to the space program as a nuclear safety officer, and that was the Voyager mission. Voyager uses a nuclear power source, and so we were looking at things that could go wrong with the spacecraft during launch. And we did a lot of crazy things, like put big chunks of rocket fuel on a rocket sled and slam it into a brick wall to see how it would break up, and look at the size of the burning pieces to see if there was enough fire there to breach the nuclear containment, because we didn't want the material to be, plutonium to be released to the biosphere and could harm people. So we're doing all these safety analysis and second guessing the engineers on the other side in NASA who were actually designing the spacecraft. We were looking for things that could go wrong. So I did an orbit insertion analysis where NASA had gone on record saying that, well, once the upper stage is released to Centaur, from the Centaur vehicle is released from the Titan launch vehicle, there was no way for it to come back in. And I did an analysis that showed that they were wrong. And I presented that, and so I ended up getting offered a job at the Jet Propulsion Laboratory, and then I was assigned to the Galileo mission to Jupiter as a power systems engineer. And that was a great experience. And I wanted to do that because, you know, if those guys did their job right, nobody would care about what we were second guessing. And so I wanted to know how I was just curious, how do you launch a spacecraft and it takes years sometimes to get to another planet and it does all these science, and sometimes you hear about something failed or went wrong, and then a few weeks later you hear a report coming out from NASA, well, everything's back on track. I'm like, well, they didn't go up there and fix that thing. How did they get it back on track? And so I was just curious. I wanted to know how it was done, and I learned. The answer was just hard work and perseverance, not giving up. When you run into a problem, I remember one problem was on Galileo, and I was all excited because the camera and images from Galileo were going to be so much better than Voyager. We're going to be closer to the planet, new technology for the camera and so forth. And then we found out that the radiation levels at Jupiter were much higher than people had predicted. And when we opened the camera and exposed it to take an image at those radiation levels, the pixels would all bloom and you get a white image and you couldn't, I'm like, oh no. And it was going to be so great. But as a nuclear engineer, I knew that you open up the aperture to take an image where the radiation comes in and then you're done. Those guys didn't break stride. Just got a little bit over here and adjust that over there, and then next thing you know, problem solved, on to the next one. I said, okay. Perseverance is a very powerful, powerful tool. And so from there, I decided to go back into the Air Force. And this assignment was at the Strategic Air Command in Omaha, what was then SAC headquarters. And this is the command that's responsible for all three legs of the nuclear triad, you know, the land-based missiles, the airborne bombers, as well as the submarine. The Commander-in-Chief SAC was responsible for selecting all the targets that all of our nuclear weapons would go after. And so up until that point, SAC was all nuclear. And I had this idea because of the accuracy of GPS and advanced technology. You didn't really need nuclear weapons to take out critical targets if you could hit critical components accurately enough. And so I coined this phrase of non-nuclear strategic weapons, where you could take out a target, do enough damage that you wouldn't have all the collateral damage from a nuclear. But anyway, that, and then from there I went to my second assignment was at Edwards Air Force Base on the B-2 program, so I was the first flight test engineer from SAC assigned to the B-2 bomber. And then after that, back to JPL as the fault protection engineer on the Cassini mission to Saturn. And as a fault protection engineer, I was the guy responsible for making sure that if there was a failure, something went wrong on the spacecraft, we'd have backup plans, redundancy, and things like that to make sure we wouldn't lose the mission just from a single failure. And so that was my job there. But at that point, I'd sort of burn out. So I worked on all these things. I've been there, done that. What's a new challenge? And so fortunately, I had been in the evenings, would go home and work on my own ideas. And before I had gone back into the Air Force the second time, one of the ideas was the Super Soaker water gun. So I had been experimenting in my bathroom on a heat pump that would use water as a working fluid. And I had a hose hooked up to the bathroom sink. I had machined these little nozzles and things, and I shot the stream of water across the bathroom. And it was so gratifying that I thought, you know, a high-performance water gun would be a lot of fun. Yes. So
millions and millions and millions of people agree with you, especially young people.
I decided at that point, I decided to go back into the military then. So when I moved to Omaha and got my family settled in and everything, got my shop set up, I started working on this high-performance water gun that became Super Soaker. Mm-hmm. The idea was in '82. It was a 10-year applying this principle of perseverance to the point where eventually I got a deal that worked. And 10 years later, in '92, it was the #1 selling toy in the world.
The #1 selling toy in the world. You can say that. That's amazing.
At that point, I decided, okay, I want to be the king of all toy guns. There were these Nerf dart guns out there, right? And so I started redesigning Nerf dart guns and taking the performance there to another level. I designed small guns, large ones, and they all worked better than what Hasbro had at the time. And I presented that to Hasbro. And I tell people, I think I intimidated them into doing a deal with me because they already had control of Nerf brand, they had all the shelf space, they were doing the commercials, so there was no reason for them to do a deal with me. But what I had was so great, if I can do say so, that I think I intimidated them because they didn't want me to take that product line to one of their competitors who could have caused them some problems. And so they did a deal with me. And so Nerf became, some of you may be old enough or may have played with the line called N-Strike. That whole product line was based on my inventions. And I learned a lesson on Super Soaker. Super Soaker was strictly a patent royalty license, meaning that using my mechanisms, and I did a number of different designs, and we did all kinds of variations that all were patented.
For people who watch Shark Tank, yes, that means you license it to the company, and so you're not engaged in then productizing it per se unless they need help.
Right, but we did. What I did do was, under the contract, any improvements that they made and improvements that I made, because I knew I was going to continue to work on it, would all fall under the contract. Right. So, but Super Soaker became successful. They started putting other products under the titled Super Soaker brand that didn't use my patents, so they didn't have to pay royalties on. So when I did the dart guns, I said, look, I want to have my own category under Nerf, and whatever you put under that brand, you have to pay royalties on. Right. And they agreed to that. So sure enough, they started putting other product under that line because it became successful. It became the #1 line under Nerf, and it just started overshadowing.
I don't think there's a birthday party for a kid that doesn't have a Nerf. Going.
So sure enough, my royalties went up on that one, and then they started coming down. I said, well, and one day I just assumed that toys go up and down because that's the normal cycle. They become popular. It's kind of like a hit record or something. So okay, you kind of expect that. But I was in the store one day and I saw all these N-Strike products, and I'm like, wait a minute. So I went reread the contract to make sure that it hadn't gotten rewritten or something that I had negotiated myself out of something I was entitled to. And sure enough, the language was there, it was clear. So I called them up and they said, no, you're misinterpreting the contract. So I ended up with a lawsuit and the whole 9 yards. But I won. It turned out really. So that was all good. So now I'm a full-time inventor. I'm working on my focus where I began, which is the heat pump that I was working on when I came up with the idea. I'm now focused on energy I've invented an engine that I refer to often as the great-grandson of the water-based heat pump. It's called a JTEC, Johnson Thermo-Electrochemical Converter. So it's an engine, and just like steam power plants use water as a working fluid, and they heat it up, and so you pump water to high pressure, that's low temperature compression, and then you heat it up and you expand at high temperature. So the plants have boilers, and they heat water up, turn it into steam, and then expand the steam at high temperature through turbines. So all engines work that way. Your car engine pulls air in at low temperature, compresses that air, you inject the fuel, heat the air up, and expand at high temperature. So you get a lot more work out of that high temperature expansion than it takes to compress at low temperature. So my engine does the same thing, but instead of pistons and turbines, I use the electrochemistry to do the compression expansion process, and instead of steam, I use hydrogen as the working fluid. So it's all solid state, no moving mechanical parts. And the thing that's exciting about that is that it can work on not only high temperature heat, but also low temperature heat. And a major investor in that company is an oil and gas company who was looking for a way of converting low temperature heat into electricity, because they'd done an analysis and they had literally thousands of abandoned oil wells where they'd gotten all the oil out, but there's geothermal heat in those wells at low temperature in the 150-degree C range. And that's too low for other engines to cost effectively convert that heat to power. But my engine could. We did a demo that showed it would work. And so they put $30 million into the company to launch it, to start the transitioning the technology out of the laboratory. So we're doing some demos now.
Move from oil and gas to a more green-friendly solution.
Yes.
With what's already there. Okay, we have. I'm getting the sign that we're on time, but I want to just add one. So Lonnie's doing incredible things related to green energy. You've done it. You've worked on energy and invention all your time. But you, like me, were a science fair student when you were younger. And so I wanted you to share how many robotics teams do you, and Linda, Lonnie's wife, is here.
This is my wife, Linda. She runs our nonprofit.
So we'll end with how many Atlanta-based FIRST robotics teams, K-12, do you guys support? Or run with the kids? The kids run it.
We call them resident teams.
Resident teams.
There's 14 of them.
14 teams.
But last year we had around 6,000 total students come through.
6,000 school students are coming through this lab to be exposed to how to invent and make things.
So our whole strategy there is to have the kids experience success in STEM before they get to the point where they're afraid of it, or I can't do that, because that attitude sets in a lot of times from peers. But when they have fun doing it and they experience that success, you can't take that away.
Exactly. Good. We'll end on that. Thank you, Lonnie Johnson. Yes. Sure.